Hello, my name's Robert Tulip. I'm giving a talk about albedo. The theme is why increasing albedo is more urgent than removing greenhouse gases for climate policy. And this reflects the views that we've been discussing within our Planetary Restoration Action Group, which you're welcome to contact us and discuss. Now, this is a diagram which was produced in a paper in 2018 called Trajectories of the Earth System in the Anthropocene by Will Steffen and other distinguished authors from Proceedings of the National Academy of Sciences. And what it shows is three axes. It starts back in the Holocene when the Earth was in the Ice Age, back up here. Then at the start of the Industrial Revolution, the temperature had moved out of the Ice Age and into this intermediate phase, and it's like the marble was rolling down the hill. And now we've reached this point of warming. And the question is, will our future take us to a stabilised Earth with Earth system stewardship, or will we cross this planetary threshold and with biosphere degradation and intrinsic feedbacks lead to a hothouse Earth? So let's just check out what our options are. If we continue with business as usual, then we're headed straight for the hothouse Earth, and it's really quite dangerous. What happens if we shift this needle and instead of business as usual, we say, let's cut emissions as fast as we can? Well, really, it doesn't make that much difference. It does shift the needle a bit towards a stabilised Earth, but we still go over the waterfall. Even if we remove greenhouse gases as fast as possible, then we're a bit like a skier who's gone down a slope that's a little bit too steep for them, and they want to climb back out, but it's really quite hard. So what we've got to do is we have to brighten the planet. We have to use solar radiation modification and prevent us going over the threshold into dangerous tipping points. So it's a bit like a canoe headed for a dangerous waterfall. With business as usual, we just go straight over. With greenhouse gas removal or with decarbonisation, well, we slow the speed at which we head towards the waterfall, but we're still likely to go over. We need to brighten the planet. That's the only thing that will prevent dangerous warming and dangerous changes to the Earth system. Now, I'd like to share how this explanation that I've given to you fits in with global climate policy. As a summary for policymakers that was published in 2019 by the Intergovernmental Panel on Climate Change in its special report on global warming of 1.5 degrees Celsius. They estimated that the remaining carbon budget is 580 gigatons or billion tons of carbon dioxide for a 50% probability of limiting warming to 1.5 degrees. Now, this excludes any action to brighten the planet, and they say that the reason that they exclude it is because of their concerns about governance, ethics, and impact on sustainable development. So, let's ask, what could a focus on increasing planetary albedo achieve? There's a very interesting paper that's just come out which looks at this exact question. They calculate that adding an average of 15 million tonnes, they call it teragrams or TG, of sulfur dioxide to the stratosphere every year, beginning in 2035 and continuing to 27, ramping up to increase the amount to 2070, average of 15 million, has recently been calculated as likely to reduce the average temperature rise by 2 degrees Celsius compared to the baseline. And they provide this very helpful diagram to show what they mean. I'd like to focus on the blue line here. So what this means is with stratospheric aerosol injection, the target temperature rise above pre-industrial is 0.5 degrees Celsius. So that corresponds to this blue line here, average of about 15, which shows the needed intervention in teragrams of sulfur dioxide per year. And it shows, look at this difference, 0.5 degrees of warming above pre-industrial, which is a fairly stable climate, compared to 2.5 degrees under this representative scenario that was the average scenario considered by the IPCC. And this is the source, McMartin et al. Scenarios for Modelling Solar Radiation Modification, also published by the Proceedings of the National Academy of Science just this month. So the point is that cutting emissions is not enough. This is a diagram showing historic emissions. Each little box is a gigaton of carbon, which is roughly equivalent to a cubic kilometre of water. So that's the problem. And all of this causes committed warming. That is carbon dioxide and other greenhouse gases that just stays in the air unless we remove it and keeps the temperature high. So how much are we adding to this problem? Each year it's about 15 gigatons. It depends on how you calculate methane and other gases, but let's say 15. So what will the impact of the Paris Accord be on this 15 gigatons that we're adding each year? Well, you might think that it would cut it to 14, 13, maybe 10. Well, no, it will actually increase it. It will increase it by 1 gigaton to an expected emission globally of 16 gigatons in 2030. It just shows how intractable cutting emissions is, how very difficult it is. And I think since the Paris Accord, it may even have gotten more difficult considering the politics of recent years. So meeting all national pledges to the Paris Accord would increase annual emissions by 1 gigaton of carbon by 2030. So the climate arithmetic. Emission reduction slows new emissions. It does nothing about the 40 times larger committed warming effects of past emissions, which will produce Earth system equilibrium at a higher temperature and a higher sea level. And that means no beaches, possibly 5 metres of sea level rise. Who knows? It's very hard to calculate. Decarbonising the economy is marginal to stabilising the climate, which requires, firstly, rapid brightening of the planet, and secondly, removal of past emissions. This is just another diagram I made from Climate Action Tracker, showing what they call optimistic policy projections. And it just shows how massive, this is in CO2, which is 3.7 times the carbon content. This includes the oxygen in the molecule. And this, I think the optimism is about cutting it after 2050, but who knows, that's what we're in for. So the climate instability problem is quite well known. Carbon dioxide concentrations over the Holocene were very stable for the last 10,000 years and then have gone up to this incredibly unstable position in recent times. This circus trick of balancing a plate on a stick is not really very stable, but it's the best outcome we can expect from net zero emissions. So these are the IPCC projections, representative concentration pathways. If we want to stabilise at akin to the pre-industrial, then we need to add another line looking at climate stability. But net zero leaves us above the danger line of 550 parts per million of CO2, plus the warming from equivalents such as methane, not even shown in this. That is a highly unstable result. So my hypothetical climate stability line here is too slow to prevent dangerous tipping points unless we take action to increase albedo. The urgent priority is to brighten the planet. This is a diagram that our Planetary Restoration Action Group has prepared, showing the various options, and it just illustrates how difficult the situation is. This is our business as usual line, showing warming of 3.5 degrees by 2070. Now, complete global decarbonisation loses the cooling effect that we currently get from the sulfur dioxide that's in coal emissions. That's not so well known. And if we add carbon dioxide removal, then we can maybe stay below 2 degrees. And if we, but the real solution is to brighten the planet. We can refreeze the Arctic, we can stabilise the sea level, we can suppress methane emissions, we can go back to normal weather with emergency regional solar radiation management to refreeze the Arctic. So I've prepared what I call a climate security timeline, and it begins with the foundation of albedo enhancement, the immediate cooling priority to brighten the planet, to reverse extreme weather, to reverse biodiversity loss, to reverse heating, to reverse sea level rise. Now, if we consider that as like the foundations of a house that we can focus on in the next decade, that gives us a foundation to then build with removing greenhouse gases. So we need to start removing greenhouse gases now, but it's going to take a long time. So it's going to take us the next a few decades to do it. And then we can put the roof on with cutting emissions. This is a reversal of the priorities that have been, of the approach that's been agreed within the IPCC. Let me give one example of a quite safe and simple solar radiation modification technology. I've spoken before about the theory of stratospheric aerosol injection. That's quite controversial, but I think marine cloud brightening to cool Antarctica is something that governments really ought to be able to agree on and implement quite quickly. So this is how our planet looks from due south. Antarctica is very white and reflective. The ocean around it is mostly quite dark, and it absorbs that heat. Now, if we say we want the ocean to absorb a bit less heat, then we can get salt water out of the ocean. We can turn it into mist, and we can send it up into the clouds. This is just a rough idea. You can see how much brighter and how much more reflective the planet would be with this sort of a ring of cold. So what would the implications be? That's the schematic diagram of one of the Marine Cloud Brightening vessels from Paul Beckwith and Stephen Salter. The results is it would be a safe, cheap and quick way to freeze the sea ice, limit sea level rise, protect biodiversity, prevent glacial melt, cool the ocean currents, reduce extreme weather, mitigate climate change, and increase international cooperation for peace, stability, and security. So the problem, the IPCC says the climate strategy, the globally agreed policy, start by cutting emissions, then think about later removing CO2, pretty much universally agreed, and then think a bit about solar geoengineering, but they really don't like it. What I suggest is that what's needed is to turn this whole order of priorities upside down. And instead, what we need to do is firstly brighten the planet as an urgent way to prevent dangerous warming, then develop the technologies to convert greenhouse gases, especially carbon dioxide, into useful products. And I see some of the work on marine permaculture and seaweed as the best way to do that, as something better than just trying to store CO2 in geological strata. And then we can continue to work on decarbonising the economy, which is a great thing to do. It's fantastic for the environment. It's very good for the economy, and it's essential. The trouble is, it doesn't really do that much to prevent dangerous global warming. So, let's see, why is albedo more important than greenhouse gas removal for climate policy? The problem is that cutting emissions, removing greenhouse gases, can't stop climate tipping points. Politics and economics make cutting emissions difficult, expensive, and slow. The world situation is a bit like a canoe headed for a waterfall. Viable cooling technologies lack the funds, publicity, and political support. The solution: reverse the IPCC priority order and put increasing albedo first. A brighter planet can avoid the climate danger zone. Cooling technologies such as Marine Cloud Brightening are quick, safe, and cheap. Fund large-scale solar geoengineering research. Governments must cooperate to implement direct cooling measures. So, looking back at our diagram, we can see that if we want to escape this threshold into a hothouse Earth, the urgent need is to brighten the planet. Thank you.